Hello viewers, welcome to my YouTube channel Lec5a. This is the fifth lecture, first part from the chapter First Order Differential Equation from the series Differential Equation and Discrete Mathematics. In this lecture, we will discuss the linear equation of the first order and its solution. So let's begin with the lecture. So first of all, we start with the solution. We start with the definition of linear equation of the first order. So this is an equation. This is an equation of the form. The form is very important. Y prime plus some function a of x into y is equal to b of x. Let me call this as equation 1, where this a and b, where a and b are certain function defined on an interval I, some I. Okay, now so any equation in this form, y prime denotes the derivative of first derivative of y with respect to x. So any equation which can be written in this form can be called as a linear equation of the first order. Now there are cases. Now you can see that this is a function independent of y. So if this is equal to 0, then we call this given equation as a homogeneous equation, and if this is not equal to 0 on I, then it is called as a non-homogeneous equation. So that's the next part. If b of x is equal to 0, this is identically equal to 0, that is for all x in I, then 1 is called homogeneous equation. If b of x is not identically equal to 0 for all x in I, then 1 is called non-homogeneous equation. So let us discuss the general solution, or let us discuss the working rule to find the solution of any linear equation of the first order. So we have this equation y dash, let me start this on a new page, y dash plus some function a of x into y is equal to b of x. Just look at this function, just look at this equation very carefully. Dy by dx plus some function into y, the dependent variable, plus the function equal to the function which is independent of y. So any equation in this form is called a linear equation of the first order. So what we do here is that the expression on the left hand side, we convert it to the total derivative of certain function. Like for example, if I multiply both the side by multiply both side by e raised to integral a of x dx. Okay, now this integral can be from one fixed point to x, okay, and it has to be a function of x, so the integrand should be in terms of t. But since we are finding the general solution, we can proceed with in this way. So multiplying this, what happened is that the equation gets converted. So we have e raised to integral of a of x dx, whole thing into y dash plus a of x into y is equal to integral of e raised to a of x dx into b of x, right? And see, our aim is to find the value of y, or find the expression which would satisfy this which contain y and x explicitly, and which would satisfy this given equation 1. Okay, now in this case what happens is that when you open the bracket, just look at the left hand side. E of ax dx y prime, that is dy by dx, plus e of integral a of x dx a of x into y is equal to e into b of x. Okay, now just look at this term, the term on the left hand side. Okay, now you can see that if you observe this minutely, you can see that this can be written as derivative of certain function. Okay, and that derivative is nothing but d by dx. So the total derivative of the function e raised to integral ax dx, okay, into y. Okay, because if you see the first term, if I apply the multiple product rule over here, I'll keep this as it is. So first term e raised to, and you have exactly that into dy by dx plus y as it is, and the derivative of e raised to integral of a of x dx, that is nothing but e raised to integral of a of x dx into derivative of this integral, whole integral. Derivative and integral gets cancelled and you have a of x. So that's become the derivative of whole expression into e raised to a of x dx b of x. Now that's it. Now when you take the integral on both sides, you will see that you will get an expression containing y explicitly without any differential coefficient. So that becomes the solution of this given equation. And whatever factor we are multiplying to this given differential equation to make this equation, to convert this equation in this form, that is derivative of certain function, it's called an integrating factor. So this e raised to integral of a of x dx is called an integrating factor in this case. Okay, so now when I integrate this further, we get the derivative gets cancelled, so you have e raised to a of x dx y is equal to into y is equal to integral of e raised to a of x dx into b of x dx plus the constant term. Okay, I just want to check in the previous whether yeah, that's fine. So this is what we have, and this is what is important. We can directly reduce the linear equation. We can, to find the solution, we can directly multiply by this factor, that's called as integrating factor, to get this equation. And to get the value of y, it's very simple. Now you take this expression to that side, so you have y is equal to e raised to minus e of x dx into the term that is already present over here. Okay, so this expression, this is what we can directly derive by multiplying e raised to ax. So if I call this as an integrating factor here, e raised to integral of a of x dx is called an integrating factor. In short, I will call it as IF. Okay. Now, so once you get an integrating factor, you have to get this equation. So that is this form. So the form is, so the solution is of 1 is given by your integrating factor, whatever you have, I'll call it as IF, into y is equal to integral of, again, integrating factor into b of x dx plus c, and then you can simplify this further to get y equal to something. So this is how the solution is given. So this is an important expression, okay, to find the solution of the linear equation of the first order. Let's take an examples. Solve first one. X plus 1 into dy by dx minus y is equal to e raised to x into x plus 1 whole square. Now, this is not in the required form. We want the expression of the form dy by dx plus a of x into y, some function into y, is equal to some function of x independent of y. So let me write down, let me see whether I can convert this in that form. So this after multiplying by x plus 1, you have dy by dx. Now when I multiply by x plus 1, we want x to be equal to minus 1. So that care is taken by the domain, by the value of y on which it has a defined value. Okay, so that x equal to minus 1 will never come in the domain. So that care is taken by the domain. Minus 1 by x plus 1 into y is equal to e raised to x into x plus 1. 1x plus 1 gets cancelled. So your a of x, so that's your equation 1. So your a of x in this case is, if I compare it to the general form, 1 by x plus 1, and your b of x is same as e raised to x into x plus 1. So now we would find first the integrating factor. So the integrating factor, I'll write down here, integrating factor is given by e raised to integral of a of x dx, that is same as e raised to minus 1 by x plus 1 dx, and that same as, this is minus log of x plus 1, so that same as log of x plus 1 the whole raised to minus 1, and since this is e is the inverse of log, you get 1 by x plus 1 as your integrating factor. So you need to in this expression, now you just need to determine, now in this expression we just need to put integrating factor and the value of b of x, and that will give us the solution. So that's what we will do. So the solution is, hence the solution is given by 1 by x plus 1, that's your integrating factor, into y is equal to integral of 1 by x plus 1 into b of x, that is e raised to x into x plus 1 the whole into the whole raised to 1 dx plus some constant. So this and this gets cancelled, and so the final answer would be 1 by x plus 1 into y is equal to integral of e raised to x is same as e raised to x plus the constant, and so you have y is equal to x plus 1 into e raised to x plus c time x plus 1. So that's your final solution. Let me take one more example. Second one. x cube minus x into dy by dx minus 3x square minus 1 into y is equal to x raised to 5 minus 2x cube plus x. So this is the given differential equation. Let us try to write down in the required form. Solution. This can be written as dy by dx minus 3x square minus 1 upon x cube minus x into y is equal to x raised to 5 minus 2x cube plus x the whole raised to whole by x cube minus x. Now here a of x is same as minus 3x square minus 1 upon x cube minus x, and b of x is same as x raised to 5 minus 2x cubed plus x the whole by x cube minus x, which is same as, now you can take x common, and so you will get x raised to 4 minus 2x square plus 1 upon x square minus 1. Again, this can be further simplified. If you put x square is equal to 2, you will get two roots, and both the roots are of the form t minus 1. So this is same as x square minus 1 the whole square upon x square minus 1, that is exactly same as x square minus 1. So that is your b of x. And the integrating factor is given by e raised to integral of a of x dx, which is same as e raised to integral of minus 3x square minus 1 into dx upon x cube minus x. You can see that the derivative of this whole term is appearing in the numerator with the minus sign. So this should be e raised to minus of log of x cube minus x, and that is exactly same as 1 upon x cube minus x. Okay, so that's the integrating factor. So once we know the integrating factor, we can write down, hence the solution is given by, hence the solution is given by 1 by, that's the integrating factor, 1 by x cube minus x into y is equal to integral of 1 by x cube minus x into b of x, that is x square minus 1 into dx plus c. Now again, here you can take x common, and you will see that x square minus 1 gets cancelled, and so you will have 1 by x cube minus x into y is equal to integral of 1 by x will remain, that same as log of x plus c, and when you cross multiply you get y is equal to x cube minus x into log of x plus c into x cube minus x. That's a final solution. Stay tuned for the next video. That's the next part of this video, this lecture. Thank you very much.